Okay, this problem's rather straightforward here. It looks kind of busy and all, but we'll get through this. The idea here on the bottom of the page, I'll highlight in green, is that first and foremost, you look at the alkyl halide, okay? If it's primary, it's going to be SN2. You don't have to think anything more about it. If it's tertiary, it's going to be SN1, and you're done, okay? Now, what you do have to think about is if you have a secondary alkyl halide, this is going to react by SN1 or SN2. And so what you want to think about is for SN2, you're going to have a strong nucleophile, right, which is negatively charged perhaps, or you're going to have a polar aprotic solvent. Okay, polar aprotic solvent. If the reaction is SN1, it's usually going to have a neutral nucleophile, like water and methanol or some kind of neutral molecule, or it's going to be a polar protic solvent. Okay, so let's go through these and we'll use the process here, okay? So first, figure out primary, secondary, tertiary. If you need to break the tie, then look at the nucleophile or the solvent or other things in there, okay? So let's go ahead and look at this. This is a methyl halide, so don't have to think about anything else. That's going to be SN2, okay? This guy here is secondary, all right? So it could proceed by SN1 or SN2. Let's look at the nucleophile. The nucleophile is negatively charged, okay, which means it's going to be SN2. Verify that. Yes, we have inversion of stereochemistry. Okay, so that's SN2, all right? Over here, remember again, that's our alpha carbon. We count how many carbons are attached to this. This is a tertiary alkyl halide, which means this proceeds by SN1. We don't need to think further, okay? Next up, we look here. We have a secondary alkyl halide, and that means it could be either. So we look at the nucleophile, it's negatively charged, and we look at the solvent. The alphabet soup is going to be, generally speaking, your polar aprotic solvents, okay? So the solvent and the nucleophile both support the SN2 reaction mechanism. Next up, we have a primary alkyl halide, so we don't need to think anything further, it's SN2. Here we have a secondary alkyl halide, so we need to think about the conditions. If we have a neutral nucleophile, okay, which is water, or a polar protic solvent, which is water, it's going to be SN1. Okay, so that's how we break the tie there. Okay, how about this? Well, we don't have any conditions at all, so this is a secondary alkyl halide, so we can't look at the nucleophile or the solvent because it's not given to us. What we look at is the stereochemistry. There's a scrambling here, so that means it must proceed by that carbocation intermediate, which is flat, planar, and so it gives us both isomers. So that's in the SN1, okay? Here, carefully look at this. We have a tertiary alkyl halide, so we know without a doubt that proceeds by SN1. We don't need to think further, okay? Here we have a secondary alkyl halide, so we want to break the tie here, and we want to look at the nucleophile. It indeed is strong because it's negative. We look at the solvent, it's polar aprotic. We've seen that before over in part D. So this guy here is going to be favoring an SN2 reaction mechanism. This reaction here is a primary alkyl halide, so it's SN2. We don't need to think about anything else. This guy right here is secondary, so it could be SN1 or SN2. So we look at the conditions. I see a neutral nucleophile and I see a polar protic solvent, so those are both going to favor SN1 chemistry. Okay? Again, I hope you have all of these factors kind of summarized on a note card. Here we're just looking for 3 things, okay? The substrate, and then, only then, if it's tied, we look at the nucleophile. If we can't make a decision, then we look at the polar solvent that's involved. Sometimes you look at stereochemistry, like in part G, to make a decision. Okay? Thanks for watching, and please do consider subscribing to my channel.